This week we'll be looking at the third form for our quadratic equations, which is called the vertex form. The vertex form is just a different way of writing out the equation. And this different form gives you different information. Right? So our standard form, that one is useful for getting the direction, the step pattern, and the y-intercept. Our factored form is useful for getting the step pattern, the direction, and the x-intercepts. And our vertex form, as we'll see in a little bit, is useful for getting the direction and step pattern and the vertex. So in this form, you can actually just pick out the vertex directly. So last week I had you guys go through and do a little bit of an activity, an online activity, and you're using kind of a pre-made Desmos graph that was similar to this. And what I had done is I'd added in the vertex form. So this here is the general form for the vertex equation. It is still a quadratic because it involves an x squared, right? X to the power of 2. It's just written in a different way, right? It's not standard form and it's not factored form because the squared means that there's two brackets multiplying together, but then there's an extra thing adding. So it's not factored form either. It's a separate form. And in this case, A, H, and K would just be some sort of numbers that would be in there, right? So if I just flip back here for a second, that's an example of one of them that might be a vertex form, right? I've replaced the H and the K. And there's no A, so the A is like a 1 there. Right over here, another example, I've just replaced the A, H, and K with some numbers for the specific graph I'm looking at. All right, so what this allows us to do is it allows us to actually just change the values for A, H, and K. It allows me to kind of slide these and just plug in different values and then see how it changes my graph. So right now what we're going to start off with is we're going to start off with, with A equal to 1. And then H is 0 and K is 0. So really this equation is just y equals x squared, our basic parabola. And there's our basic y equals x squared parabola. Okay, let's look at our A value first. Well, we know from the standard and the factored form that the A value, all it does is affect the step pattern and the direction. So sure enough, if I make my A value larger, I get a bigger step pattern, right? 2 would be, it would be a step pattern of 2, 6, 10, right? So 2, and then so forth, 6 and 10. And, if I make that A value bigger, my step pattern gets even larger, right? Okay, so over 1 up 3 now. And certainly if I bring that back to 1, there's my basic parabola. And if I make that A value negative, now the step pattern is negative, -1, -3, -5, and it's opening down. So you know what? Step pattern doesn't change. Whether you're in standard, factored, or vertex form, A value gives you the direction and the step pattern. And the A value in all three of the forms is exactly the same. So if your A value is 1 in standard form, then it's also 1 in factored and vertex form. And that makes sense because even if you switched forms, your parabola still has the same step pattern. Okay, let's see what happens when these H values is changed next. All right, so let's say I had minus 1 in there. Okay, so when H is a 1, it looks like that slid the graph to the right by 1. And that sliding, we call sliding translating. So I'd say the graph was translated to the right by 1. And if I make H bigger, I'll make it a 2. Okay, now my parabola has been translated to the right by 2. I'm always comparing it back to my basic parabola. And certainly if I took that H value and I made it a negative, now I've translated it to the left. My parabola slid to the left. -2 slid to the left by 2. We'll put that back to 0. All right, so what is H doing? H is just translating or moving the parabola left and right. Now we should notice here that there's a negative in the equation. So that means whatever shows up in the brackets, right? If it's x minus 1, that would actually be translating to the right by 1. Or if my brackets said x plus 1, it would actually be translating to the left by 1. Right, let's look at that for a second. If I made H -1, I would have x minus -1, x plus 1, and that made it go to the left. So whatever's in the bracket, it's always opposite to that. Same as factored form. So the nice thing is that matches up, right? In factored form, anything in the bracket, you switch the sign. Same thing here. The value that's in the bracket, you switch the sign. The value that's not in the bracket, as we'll see in a moment, you don't switch signs. So kind of a easy rule is that in quadratics, anytime you take something out of a bracket like this, you swap the sign. All right, we'll put h back to 0, and let's look at k. So we have this plus k at the end. Let's see what happens. Let's say I did a plus 1 at the end. All right, what did that do? It translated my graph up by 1. Cool. All right, I make it 2, translate up by 2. Back to 0. If I make k -1, it translated down by 1. It slid down by 1. Okay, so all that k value is doing is sliding it up and down. Now, if we know how much our parabola has been slid, left or right, and up or down, we actually know where the vertex is. And that's why it's called vertex form, is it gives you the coordinates of the vertex. Let's do an example here. Let's make h a 2, and let's make k a 1. In that case, my parabola, basic parabola starts at 0, 0, that's the vertex. But my parabola was translated 2 to the right and 1 up. So every single point moved 2 to the right and 1 up. So my vertex, which was at 0, 0, is now at 2, 1. And I'll be able to see that in the equation because those numbers are just going to show up. 2 for my h, 1 for my k. So if you have your equation in vertex form, you can just immediately tell me what the vertex is. All right, so let's go back to the lesson. We'll kind of summarize all of that, and we'll do some examples. All right, so what did we find out? The a value gives the direction and step pattern, just like any other form. And sometimes you'll hear that described as stretching or compressing. So you'll say, okay, if my a value is 2, it means that it was stretched by 2. It's stretched vertically. It's kind of a skinnier parabola. Or if my a value is 0.5, it was compressed. It was squished down. But really nothing has changed with a. It's the same as all other forms. Right, let's check the h value. We noticed h did a horizontal translation, which means how did it move left or right? And k, we noticed k was a vertical translation. How much did it move up or down? And what we also notice is that the vertex is just at these numbers. So it's at h and k, because the vertex went h right or left, and k up or down. All right, and the only thing is we have to swap the sign here for the h because it's coming out of the brackets. It has the negative there already. Let's do some examples. All right, first one. All right, looking at this guy. My vertex, well, I can pick out the h and the k value. First of all, I know it's vertex form because it's a bracket squared, right? The same bracket squared plus something. So it's matching up with that sort of form, right? Something squared plus a number. Okay, so in this case, my vertex would be, I'm going to switch the sign, +1 and +3. I only switch the sign coming out of the bracket. My direction, well, there's no a value, so the a is like a 1 here. So it would be up, positive. And 1 means our basic step pattern, 1, 3, 5. Now the last thing is the number of zeros, right? Zeros or x-intercepts, those mean the same thing. Okay, so let's think about this for a minute. My vertex is at 1 and 3, and it's opening up. Let's make a rough little sketch here. Okay, I don't need an exact graph, but my vertex is approximately 1 and 3 somewhere up here, and my parabola opens upwards. So does it ever hit the x-axis? No. So no zeros, no x-intercepts, no roots, right? Those all mean the same thing. All right, so at this point, I'll get you guys to pause the video, try the next couple examples out here, and then we can come back and check your answers. All right, so hopefully you had a chance to try the next ones out. Let's see what you got. Okay, next one, it is vertex form. My vertex would be at, switching the sign out of the bracket, +3 and +4. My direction would be up because it's positive. My step pattern would be doubled, so 2, 6, 10. And if we think about like a little graph here, just kind of a rough sketch, vertex at 3 and 4 somewhere here, opening upwards. Once again, it never hits the x-axis. No x-intercepts, no zeros. All right, next one. All right, this guy next. All right, once again, switch the number that comes out of the bracket, so the h value. So my vertex would be at -1 and -5. Only switch the one. Oh, I made a mistake there. -5. Only switch the one that comes out of the bracket. -1 and -5. Direction, a value is not there, so a value is a +1, so up. A value is 1, basic step pattern. And all right, let's think about where this guy's at. -1, -5. Uh-oh, I think I made a mistake on this guy here too. So let's see here. -1, -5 would be down here somewhere, right? And it would be opening upwards, something like that. So in this case, there would have to be 2 zeros. Sorry, that's a little bit messy there. Next one. All right, in this case, once again, switching the one that comes out of the bracket. So this would be at -3 and +1. Direction would be down because my a value is negative. Step pattern would be multiplied by -2. So -2, -6, -10. That was actually a common mistake on the assignment. Make sure that if your a value is negative, it makes your step pattern negative as well. And the zeros, let's see, -3 and 1 would be here, opening down. Yep, it hits the x-axis twice. 2 zeros. All right, last two examples. All right, this one's a little bit weird because you look at it and you say, hold on, you could actually consider this as standard form, right? X squared plus, well, there's no x term. Maybe it's just 0x, right? Right? And then +4. So this could actually be considered standard form, or it could be considered vertex form because it is something squared plus our number. Okay, so if we consider it as vertex form, which we can do, there's no a, so the a is a 1. There's no h adding inside the brackets, right? Because it's x minus h squared. So that means my h must be a 0 if it's not there. X minus 0 squared plus 4. So I can kind of think of it as this, right? I could say, okay, this is the same as like y equals 1 for my a, x plus 0 squared plus 4, right? If I wanted to actually include my a, h, and k value in there, it would look something like that. But it's too messy, right? So if we're not going to add 0 and leave that in, and we're not going to just leave an a value of 1. So we simplify it down to this, but that's actually what the a and the h and the k values would be. So where is my vertex? Well, it's at 0 and 4. Direction, up. Step pattern, basic 1, 3, 5. Number of zeros, let's see, 0 and 4. It's my vertex. Opening up, no zeros. Never hits the x-axis. All right, last one. Vertex would be at, switch the sign, -1, -2. Direction, positive, so up. Step pattern would be multiplied by 0.5, right? A half. So 0.5, 1.5, 2.5. And zeros, let's see, -1, -2, opening upwards. My step pattern is small, right? That's why I made it really wide, right? It's growing slowly because of that small step pattern. But it is going to hit twice, so 2 zeros. All right. Last question. Okay, so now what we're going to do is we're going to look at a little bit of algebra. So in this case, find the equation in vertex form of the parabola that has zeros at -1 and 3 and has a y-intercept of 9. All right, so let's think about this for a minute. I'm just going to scroll to the top. If we want to make an equation in vertex form, what do we need to know? We need to know the step pattern, the a value, and we need to know where the vertex is, because that gives me an h and a k value. Okay, so let's look back here. How are we going to figure those things out? Well, I really don't know anything about my vertex, right? I'm given the x-intercepts and the y-intercept. So hold on here. I don't know anything about my step pattern or my vertex. So you know what? I have to just start with the information I'm given. A parabola that has zeros? Well, let's start by making an equation in factored form. Because, I mean, that's the information I'm given. All right. Zeros at -1 and 3. That would give me a factored form x plus 1 times x minus 3. And the only thing I wouldn't know about my equation would be the a value. But hold on, maybe I can find that a value. We've done questions like these before. I know the y-intercept is 9, so I know that I could plug in -9, 0 and -9, because that's a valid point on my equation, on my parabola. So let's plug in that point and solve for a. Okay, replacing y with -9, replacing x with 0. Now we can solve this guy for a. Brackets first. 1, -3. Gives me a times -3. Dividing by -3. That gives me a is equal to 3. Okay, good. And I've circled it because I know that that a value is always the same. So I'm partway there. I do know what my step pattern and my a value is for my vertex form, because it's always the same for all of the forms. All right. So I'm partway there. I still need to figure out where this vertex is, though. All right, well, hold on. Once again, we've done some questions like this. If we know where the x-intercepts are, where the zeros are, we know that our parabola, or sorry, our vertex has to be halfway in between them, right, on the axis of symmetry. Okay, so like we were doing in previous questions, let's find the axis of symmetry. So zeros at -1 and 3. Let's find our axis of symmetry. Okay, halfway in between, right? So add them, divide by 2. -1 plus 3, divide by 2. All right, so we can get our axis of symmetry. Gives me x is equal to 1. And then we can find our vertex by plugging that x number into our equation. We have an equation to work with now because we made the factored form equation. So sub the x equals 1 into our equation in order to get the vertex. All right, so I go to my equation, my factored form one that I made. I replace x with 1. And we'll solve this guy. Brackets first. 2, -2 gives me -12. And now we know where the vertex is, right? Vertex at 1 and -12. right? Because I found my axis of symmetry was halfway in between these two x-intercepts. And I know my vertex has to be on that axis of symmetry. And this is the point on my graph or on my parabola that works. So that is the vertex. So we have all of the information we need now. We know the a value. We know the vertex. Okay, I ran out of room, so we'll go back up here. So vertex at -1 and -12. I have my a value is 3. Okay, so now I write down my vertex form. I copied that from the top of the lesson. And in this case, I know all of the things. I know my a value. I know my h, which is the x coordinate of my vertex. How much did it go to the right in this case? And I know my k value. How much did it go down by? Where's the vertex? 1, right? Swapping the sign, so +1 and -12. So all I did is replace h with my 1 and k with my -12. There's my equation in vertex form. So this is the final form that we'll look at, and it's one of the more useful ones because when you start to model parabolas, a lot of the time you want to find where the vertex is. Because, let's say you're modeling profit or something like that, a profit of a company, you would want to figure out where the maximum profit is. Or maybe if you were modeling a cost, you'd want to find where the minimum cost is. And those points are always the vertex, right? The vertex will be the top or bottom of your parabola. So if you have an equation or if you've made your equation using information like the x-intercepts, or maybe you had a standard form equation already, if you can switch it into a vertex form, well, now you'll know where that vertex is, right? You'll know where that max or that minimum point is.